All right, this is lesson number 4 for Unit 8, Part 2. We are not learning any new information today. We are just going to take what we know about trigonometry, and we're going to add in what we already know about these other methods of solving for missing sides of triangles. So, do we always need trig to solve for a side? The answer is no, we don't always need to use trig. So there's lots of different ways to find the missing side of a triangle, and it all depends on what was given to us. So I have a little chart here that says the name of the strategy, when should I use that strategy, and then what's the formula that I need to know. So this is a great study tool. If I were you, I would probably memorize this, okay? So let's start with Pythagorean theorem. I'm going to use it when I have 2 out of 3 sides of a right triangle, and I'm looking for the third side. You'll also use Pythagorean theorem if you don't know anything at all about any of the angles. So if there's no angles marked at all, you're probably going to use Pythagorean theorem to find the other side of the triangle. Here's the formula. Pythagorean theorem is a squared plus b squared equals c squared. Then we talked about 30, 60, 90 triangles. The only time I can use 30, 60, 90 pattern is when I actually know the angles are 30, 60, and 90 degrees. Here's the pattern from that. Across from the 30 is A, across from the 60 is A root 3, and across from the 90 is 2A. Then there's 45, 45, 90. We use that when I know that the angles are 45, 45, and 90 degrees. This happens when it's an isosceles right triangle. And the pattern for that is across from the 45s are A, and across from the 90, the hypotenuse is A root 2. Finally, I use trigonometry when I only know one side of the right triangle, and the angles are not 30, 60, 90, or 45, 45, 90. So there are some other angle measures besides those. Then I would use SOHCAHTOA. And so here's a reminder on SOHCAHTOA. And I like to write it like this so I can remember what goes where when I write my fractions. So before I even go and solve all of these, I'm going to go through and choose the method for each of these just based on what they gave me. So starting with number 1, I know 2 out of 3 sides. I don't know anything at all about these angles, so this is Pythagorean theorem. Going down to number 2, we'll come back and solve, but going down to number 2, look at this. I only know one side. I know the angle's 28, so it's not a 30, 60, 90, not a 45, 45, 90. This is trig. Number 3, it's a 60-degree angle. Got to be 30, 60, 90. This one, these angles are marked congruent, which means those are 45 degrees. All right, so if I know that these 2 angles are congruent, that means it is an isosceles right triangle. So these sides are congruent, but more importantly, these angles are 45. So it's a 45, 45, 90. And then finally, last one, again, an angle measure that's not 30, 60, 90 or 45, 45, 90 means I'm going to be using trig again. All right, so let's go back and solve for these missing sides. First one, Pythagorean theorem. Now, you might notice that this is a triple, okay? So this is a 9, 40, 41. 9, 40, 41, but it's a 9, 40, 41 times 2. 9 times 2 gives me 18. 41 times 2 gives me 82. So 40 times 2 gives me my answer, which is 80. All right, if I didn't recognize the triple, I could solve for x by doing Pythagorean theorem. Here's the setup for that. 18 squared plus x squared. Remember, it's got to be the 2 legs that we do, equals the hypotenuse squared, so equals 82 squared. And if I square the 18, square the 82, solve for x, guess what I'm going to get? 80. So I'll let you try that part on your own. Answer, x equals 80. All right, that was Pythagorean theorem. Let's move on. The second one we decided was trig. The angle measure is not 30, 60, 90 or 45, 45, 90. So from this 28-degree angle, I know the opposite side is 18. I know the adjacent side is x. I don't know anything about the hypotenuse. So for O and A, I'm going to use tangent. All right, it's a TOA. So tangent 28 is opposite over adjacent, 18 over x. And as a reminder, when the variable is on the bottom, that's when I swap the positions. So I'm going to switch the x with this entire thing. So my answer is going to be x equals 18 over tan 28. 18 over tangent of 28. Now that literally means in my calculator, I'm going to do 18 divided by tangent of 28. And there's my answer. It's going to be 33.8, so we'll round it up to 34. Oh, no, sorry, I lied. We're looking for a side, so actually let's round it 2 decimal spots, 33.85. So just to clarify, when I'm looking for an angle measure, that's when I would have rounded it up to 34. But this is not an angle measure that I was looking for. It was a side. So I am going to round it just 2 decimal spots. So 33.85 is my answer for this one. Number 3 we said was a 30, 60, 90. So as a reminder on how to solve 30, 60, and 90, we want to make sure that across from the 30-degree angle, that's the A. Across from the 90-degree angle, that's the 2A. Across from the 60-degree is the A root 3. So the number they gave me is the A root 3 side. So this is the kind of the harder thing we have to do, which is solve for that A. So if I know 18 has to equal A root 3, then I have to get A by itself by dividing over the root 3. So 18 divided by root 3, I always use the trick. 18 divided by 3 is 6, tack on the root 3. Now that's the A, which is this side. So 2 times A, which is actually what I'm looking for, is 2 times 6 root 3. So it's 12 root 3. All right, 45, 45, 90. So the formula is A root 2. So this one's nice and easy because I know this side is 3, which means this side has to be, I'm just plugging in 3 for A. So it's 3 with a root 2, and that's my answer for X. And finally, this one we said is trig. The angle they gave me is 49 degrees. From that angle, I want the opposite side, and I know the hypotenuse. So opposite and hypotenuse is going to be so, or sine. So it's sine of the angle they gave me, which is 49 degrees, equals opposite over hypotenuse, x over 30. This time, the number is on the bottom, so I don't need to swap. I'm just going to multiply the 30 to the other side. 30's cancel. I get x equals 30 sine of 49. So I'm going to type in 30 sine 49, hit enter. 22.64 is the magic number. 22.64 is my answer. And that's the lesson. So it's nothing new. It's just deciphering when do I use what. And we're bringing back in the 30, 60, 90 pattern, the 45, 45, 90 pattern, and the Pythagorean theorem along with trig. Because at the end of the day, for right triangles, these are all options for us to solve. All right? You're going to try the homework, which is worksheet 4, and it's very similar to the 5 problems I just went over. So give it a go, and that's it. Thanks, guys.